Still looking at these angles formed by transversals. Still dealing with this sheet. Hopefully we're okay with. I know we've already definitely gone over vertical angles. We've gone over corresponding angles. I've alluded to alternate exterior angles without directly going over them. So we definitely have some other angles to kind of come up with that we will get to as we go. So hopefully we'll do those right now. We'll see. So it says suppose angle A in diagram at right equals 48 degrees. So I know that this is 48 degrees. It says use what you know about angle pair relationships to determine angle B. Well, I know that this is the bottom left and this is the bottom left. So this must equal 48 degrees because of corresponding angles, because these lines are parallel. Again, it's super important these lines are parallel. And hey, look, if these are vertical angles, they should also be congruent. So I know that B equals 48 degrees, right? Because of corresponding angles and then vertical angles. Julia is still having trouble seeing the angle pair relationships clearly in this diagram. Her teammate Althea explains, when I translate an angle A along the transversal, I notice its image and angle B are a pair of vertical angles. That's this angle right here. It slides down here and it becomes a vertical angle with B. That way I know that angles A and B must be congruent. Use Althea's method and tracing paper to determine if the following angle pairs are congruent or supplementary. Be sure to state whether the pair of angles created are translation, is a vertical pair or forms a straight angle pair. So we're going to say if they're the same or if they just add up to 180. So I think a good way to do that would be using the same colors that we were using in our previous video. So hey, I know that this is orange, and then the bottom left, these lines are parallel, so the bottom left would also be orange. Well, now, this would have to be green, right? And an orange and a green should add up to 180, so these ones must be supplementary angles, right? They have to add up to 180 degrees. They're not necessarily equal to each other. So here, I'll start with this one being orange, and then, again, these lines are parallel, so top right, and then, hey, look, these are vertical, so this would be orange. So these ones appear to be congruent. And then finally here, these are orange, and I will slide this down. These would be orange, and uh-oh, look at that. Those must be green, right? Not the same, but green, and those would be supplementary. So hopefully we're seeing what's going on with that color coding on why some of these are supplementary relationships and some of these are congruent relationships. So alternate interior angles theorem. In problem 193, Althea showed that the shaded angles in a diagram are congruent. These angles are called alternate interior angles. So let's look. These were the alternate interior angles. And we know that alternate interior angles have to be congruent, right? Again, if this is orange, then this is orange. And if this is orange, this is orange. So there we go, those alternate interior angles. Now, what does it mean to be alternate interior angles? Well, it means they alternate across the transversal. Here's the transversal. Alternate means they're on opposite sides. Interior means they're inside the parallel lines. So alternate interior angles alternate across the transversal interior of the parallel lines. That's what alternate interior means. So they are called alternate because they are on opposite sides of transversal, and interior because they're both inside, that is between the parallel lines. Here we go. Now we go over here and we can fill in alternate interior angles. And we know that alternate interior angles are a congruent relationship. All right, is there another pair of alternate interior angles in this diagram? Yeah, I would say these are alternate interior angles as well. So angle DCF and angle EFC are also alternate interior angles. Think about the relationship between the measures of alternate interior angles. If the lines are parallel, are they always congruent? Yeah, I would say so. Are they always supplementary? Complete the conjecture. If lines crossed by a transversal are parallel, then alternate interior angles are, again, we'll go right here, and we'll say that they are congruent. That's the relationship. Instead of writing conditional statements, Roxy likes arrow diagrams. And arrow diagrams are no different. It's just like this should say if, and this should say then. It just is literally the most minute of shortcuts if lines are parallel, then alternate interior angles are congruent. It just cuts out the if and then. Nothing spectacular with the arrow diagrams. So it says this arrow diagram says the same thing as a conditional statement you wrote in part B, right? How is it different? Well, it doesn't say if and then. So prove that if parallel lines are crossed by a transversal, then the alternate interior angles are congruent. That is, use rigid transformations. And again, the rigid transformations we would translate it from here to here, and then we would reflect it across for the vertical angle. So nothing terribly exciting there. I'm going to pause and set up the rest of this. Side interior angles, and hopefully using context clues you can see same side interior angles are supplementary. That means they should add up to 180 degrees. So let's see if that's true. So it says, I think I want this one. The shaded angles in the diagram at right have another angle pair relationship. They're called same side interior. Why do you think they have this name? Well, they're on the same side of the transversal, right? They're right of the transversal, but they're inside the parallel lines. So I think that's why they have that name. So what is the relationship between angles formed of same side interior angles? Well, here, this would be green. I'm sorry, orange. I have so much trouble with orange and green. I don't know why. Bottom right. So this would be orange, which would make this green, which would make these supplementary angles because they are different. So if lines are crossed by a transversal are parallel, then the same side interior angles are, we'll say, supplementary. Right? So Claudia decided to prove his theorem as follows. He used letters in his diagram, and he came up. Then he wrote A plus B equals 180. A plus B equals 180. They're supplementary. A equals C. Is he correct? Yeah, A equals C because they're corresponding angles. Says finish his proof. Explain why same side interior angles are congruent. Well, he's already said that A plus B equals 180, right? So if A plus B equals 180 and A equals C, well, I can go over here and change this to C plus B equals 180 degrees. And now look what I just proved. Same side interior angles are congruent, or supplementary, I'm sorry, they add up to 180. So I can substitute that A with the C and prove that. So there we go. Now we have the theorem graphic organizer. Again, I don't really use the theorem graphic organizer. I really hope that you guys are filling this out. Have a picture of same side interior, have a picture of vertical, have a picture of corresponding, have a picture of alternate interior. I'm guessing you can guess what alternate exterior is. I don't know if we're actually going to get to that. If we don't, I'll do that right now. Alternate exterior essentially is going to be the following. Here's what let me set this up. Okay, I'm going to tell you right now, I'm going to try and trick you. So here's what alternate, don't let me trick you. Here's what alternate exterior angles are. Alternate means they're on the opposite side of the transversal and they're outside of the parallel lines, right? Instead of interior, they're exterior. So here's what I'll say. Hey, this line is, this angle is orange. So I know that this angle must be orange because they correspond, which means I know that this angle must be orange because they're vertical. So there we go. I've proven that alternate exterior angles are congruent. So I told you I was going to try and trick you. What's the error? Hopefully you caught that I never said these lines were parallel. What I just said is not true if these lines are not parallel. These lines have to be parallel for alternate exterior angles to be congruent. So we would go back in and say, you know, again, congruent. This is only true if these lines are parallel, but we have an example of alternate exterior angles as well. Alrighty, so now it says the team reasoning challenge. Again, another fun lesson here. We're just going to try and fill in as much of this as we can. It's a little tricky to sort of do this. My handwriting is going to fail me, and I'll do the best I can. Let's see what we come up with here. So I know that this is 57 degrees because these are vertical. I know that these angles are supplementary, right? So this must equal 100 and what? 23? That's 123, 170, 180. I know that this must equal 123 because they're vertical. So I have so far supplementary and vertical angles that have allowed me to prove this. So now, how do I jump from here over here? Well, I can't yet, right? Maybe I can later, but I can't yet. But I know that these lines are parallel, so I can jump down here. I know that this R must equal 57 because that's top left, top left. Those are corresponding angles. And if that's the case, then U must be 57 because those are vertical angles, right? Those are vertical angles across the X. I know that 57 plus S plus 81 equals 180. 57 plus S plus 81 equals 180. I know that because I have supplementary angles that are straight line. So that means that 138 plus S is equal to 180. If I subtract the 138 from each side, S is going to equal to be 42 degrees. So S is 42 degrees. 42 plus 57 is 99, plus 81 is 180, so that looks good. And then U and V are supplementary, or they are vertical to 100. These 42 plus 81 adds up to 123, right? So this is vertical to 123, or it's supplementary to 57. Doesn't matter. A lot of different ways that we can prove that. So now, hey, look, these are also parallel lines. So what's going on here? Do we have any corresponding relationships that I can exploit? Look at that, 81. I know that Q and 81 have to be the same. So this must equal 81, which means that this must equal 81 because they're vertical, which means that this must equal 99 because they're supplementary, which means this must equal 99 because they're supplementary or because they're vertical. So kind of a fun problem, a lot going on here. Hopefully you guys caught that. And I think that does it for 133.